Anna, like many of us, she glued to her phone, scrolling endlessly through social media. Suddenly, she saw a one post about viral foods on social media that catch her eye, a mouth-watering ad for the latest viral food trend. Everyone talking about it and it looks too tempting to ignore. Immediately, she heads straight to the shop to see what all the hype is about. In there, she tries the food, and this becomes her routine because one bite turns into a habit. Every week, it's something new, loaded with sugar, crabs, and temptation for her. After a few weeks, she went to the hospital for medical checkup and the doctor said she had diabetes. But little did Anna know the sweet indulgence come at a price. Over time, the sugary choices lead to a devastating diagnosis, and there is diabetes. So, what is diabetes? Diabetes is a condition when your body cannot properly use or produce insulin, a hormone that helps regulate blood sugar levels. This can lead to high blood sugar, which over time can cause serious health problems. There are two main types: type 1, where the body doesn't produce insulin, and type 2, where the body doesn't use insulin properly. More than half of people living with diabetes did not take medication for their diabetes. Diabetes may cause blindness, kidney failure, heart attack, stroke, and more chronic disease. Diabetes can be treated and avoided with diet, physical activity, medication, and regular screening and treatment for complication.
Next, I will explain about the implementation data. The data that we have specified from our big data, our variable X is age group and variable Y is number of diabetes patients enrolled. We started with age group of 18 to 19 to age group of 60 to 64. Now, I will explain about the graph. This graph shows a sharp increase in the number of diabetes patients enrolled as the coefficient of X rise. The trend indicates exponential growth, emphasizing the strong correlation between the coefficient and patient enrollment. So now I will explain manual calculation for quadratic curve. So we know that quadratic equation is y equal to a plus bx plus cx squared. So here we have coefficient matrix and augmented matrix. So we know the coefficient matrix is ax equal to b and augmented matrix is x equal to a multiply b. So we continue with elementary row operation. We use ERO to show that system is consistent or inconsistent. After the ERO, we got the system is inconsistent. Because the system is inconsistent, so we have to use normal system. We know that coefficient matrix of normal system is matrix A transpose multiply with matrix A multiply X equal to matrix A transpose multiply with matrix B. So we use elementary row operation to reduce it until REF. After the reduce, we can make it in equation to find the value of A, B, and C. After that, we can get quadratic equation like this. Continue with least square approximation error. We know to find least square approximation error is error equal to b minus a multiply with x. Second, we multiply a with x first. After that, b minus with ax. So we get the least square approximation error like
Now, I
this.
would like to explain on our finding. We opt for three decimal places for clarity and practical accuracy during manual computation. This balance is essential for a manageable yet precise analysis. If we refer back to our equation that we obtained just now, we can see that C value is more than 0, so the shape will be an upward parabola. To find the least square approximation error, we use the formula b minus ax. We can say that ax represents the predicted value or the value that the best fit quadratic curve line went through. If we see here, the age group between 20 until 24 has negative predicted value. This is due to the nature of the best fit quadratic curve. The y value can be negative if the slope causing it to drop below 0 when it changes from downward slope to upward slope. From here, we can conclude that the quadratic curve is quite unsuitable for this data because it is impossible to have negative value for the number of people that are affected by diabetes. Referring to the least square approximation error vector, which contain both large positive and negative value, where positive value indicates under prediction and negative value indicates over prediction. If it is positive error, it means the actual point are above the line, where the negative value means the actual point are below the line. The large positive and negative value might indicate that the model is not an optimal representation of the data. This is because a value that is near or equal to 0 is a good sign that the model is an optimal representation of the data. But this is not the case in this study. We also can see that it is not an optimal representation of the data by looking at the large magnitude of least square approximation error vector.
I will walk you through the maple coding process used to analyze our dataset, which examines the relationship between age groups and the number of diabetes cases. I will explain the commands we used, their purpose, and how they help solve the problem step by step. To start, we visualize the dataset to better understand the trends in diabetes cases across different age groups. Here are the code used for this step. We define the data in two arrays, whereas x as the age group indices and y as the number of diabetes cases. Using the point plot function, we generated a scatter plot which revealed the diabetes cases increase significantly with age. This step is crucial for identifying trends visually. Next, we move to linear approximation to model the relationship mathematically. The steps involve constructing a design matrix, solving the normal equations, and finding the best fitting line. Here are the codes. Next, we move to linear approximation to model the relationship mathematically. The steps involve constructing a design matrix, solving the normal equations, which is A transpose times AX equal to A transpose times Z, and finding the best fitting line. Here are the codes. Notice that we find the determinant of A transpose times A to determine whether the normal system has unique solution or infinitely many solutions. After forming the normal system into augmented matrix, we then use the reduced row echelon form function to find the solution of the normal system, and then the solution is used as coefficients of the linear model. What is left next is only to plot the graph to visualize the linear model. After finding the linear model, we evaluated its accuracy by calculating the error vector. This represents the difference between observed and predicted values. The code for this step is as follows. The first line calculates predicted values AX based on the linear model. Then we subtract these predictions values from the observed values B to find the error vector. Lastly, we calculate the Euclidean norm of the error vector using norm function, which gives us a single value representing the model's overall
That's all
area.
from us. Thank you for watching our video.